Good evening, sir.
Good evening, sir.
Good evening, sir.
Hello and good evening, everybody. Actually, the mic
Good
was
evening,
not.
sir.
Yeah, good evening. You people were talking to me, but my mic was not on. So okay. So how many are there? Everybody is there. Yeah, Samir Verma is there. Suleka Madam is there. Pritam,
Good evening, sir.
Kapoor. Yeah, good evening. Hima, Kedari, Avinash, and Abhishek Sharma. So all of you are there. Nice and okay, today we'll be going with another software, and that is RCDC. Okay, how many of you have heard the name RCDC? Anybody?
Yes, sir.
अरे क्वेश्चन इतना
Yes, sir.
इतना डिफिकल्ट है
Yes, sir. सुना है.
सुना है okay because that is
Yes, yes. स्कूल में सुना था.
yeah
सॉरी, स्कूल
that
में नहीं, कॉलेज में.
yeah कॉलेज में हेलो
यस सर.
कॉलेज में सुना था
यस सर, वो सॉफ्टवेयर. हाँ सर, वो सॉफ्टवेयर की क्लास अरेंज करवाई थी एक बार, तो सुना था.
right that's why there were a presentation of that software. I'm just
यस.
going to give you some feedback about that software because this software is basically it was prepared by a person in Mumbai, Prakash Bajaj, and he used to sell that software with the name that Planwin, Framewin, and RCDC. But later on, as it became more and more popular, and that Bentley company was also in search of such software. Bentley took over, or you may say that that person Prakash Bajaj has sold his entire rights to Bentley, and now it is a property of Bentley. So now under Bentley, and Bentley is a company who also owns Stadpro. Bentley का तो नाम सुना होगा ना?
Yes, sir.
Sir.
Yes, sir.
Yeah. So Bentley,
Yes,
basically
sir.
Bentley is a very giant company in software, and ANSYS and all these softwares are owned by Bentley, and Bentley is also a software consultant to NASA. So you can imagine what a big uh, company it might be. A giant, I will say, giant company. And this Prakash Bajaj um, uh, has a collaboration with that, and now under Bentley, this RCDC software is uh, marketed in all over world. Initially, for some say maybe about 10 years, it was a property by S-Cube. S-Cube was the name of the company that was run by Prakash Bajaj, and he developed that entire software. And then definitely Bentley has done more research on it, and advanced things came into picture. Uh, but now RCDC is a software which does not do any. It does not have any analysis engine. So you have to create your model in either in SCAD Pro or in ETAB. Hello. Yes. Avinash wants to ask me anything? Am I audible? Hello?
Yes,
Excuse me,
sir.
sir.
Yeah. Yes, go
सर,
ahead.
लास्ट टाइम आपने बोला था मतलब हमारी batch को कि हम इस बार मैनुअल कैलकुलेशन से शुरू करेंगे, तो मैं कुछ तो रॉन्ग बैच में हो क्या सर अभी?
No. You are not in a wrong batch. You are in the same batch. Actually, see, I think it was.
सर,
Yes.
मैंने सुलेखा मैम से भी आज बात की, उन्होंने भी बोला कि इससे पहले एक बेसिक्स का क्लास था, मतलब जो है पूरा
होगा 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 अभी वो साइमल्टेनियसली सी
मिस किया है या फिर
yeah yeah
क्या, मुझे समझा नहीं सर.
yeah let me explain that
Yes.
properly. See, actually the basic will also be carried, but simultaneously now I will have every alternate session will be conducted by me, and another session will be conducted by Anil sir. Anil sir will uh, focus on basics. But I will also give you some glimpse of that, and that is what I am today. I am taking a course, or today I will be uh, presenting some of the basics, and so that you will not find RCDC that you cannot apply. See, RCDC is very simple software. One can learn RCDC within hardly 10 to 15 days. So provided, again, you will always say that, I always say provided, because see, engineering excellence is different thing, and learning software is another different thing. So the person, if you are very good in your engineering, that means if you know how to draw shear force, bending moment, if you know how to analyze the structures, maybe continuous beam, fixed beam, single span beam, or a frame. So it's a process. We start with the point, then we go to line, then we go to surface, then we go to solid, like that. So first you have to go through your engineering mechanics, then strength of material, then theory of structure, then analysis of some that advanced concepts in analysis that are used in indeterminate structural analysis. Then there is linear analysis, non-linear analysis. All these analysis things are carried in any software. And design part, for design part, what you need, how to design a member. Whether you are designing a member in steel structure, then you must know a design process and codal provision for design of beam, column, or any what I will call girders, etc. So that is a structure, steel structure. In RCC, what we do, we design beam, we design slab, we design column, we design footings, we design combined footings, raft or mat foundation, then we design flat slab. So all these things need design and design information, as well as you must be very well conversant with one of the code of any country. Maybe you may be very well concerned with right now we are in India, so we are talking about Indian codes, but in Gulf you have to go for British as well as ACI code, or sometimes European code. If you are in any other country, say New Zealand, you will have to go for New Zealand code, like that. But at least you must know one code. Maybe IS 456, IS 875, IS 800, all that. Or you may go for ACI codes, or ASCE codes, or Euro codes for reinforced concrete design. So that is a design part. Okay, so all these things are covered in your syllabus, which is under graduation or under post graduation. But later on, you don't have that time to do the things manually. It takes a lot of time, and you have to do same work again and again. For that, the software will help you. So that's why we are going for software. But software will help you only when you know the theory. Is that clear?
Yes, son.
Yeah. So understanding the structure, understanding the analysis, understanding the behavior is a essential, or I will say it's a mandatory part. If you want to develop your career as a structure engineer, then all these things are very, very important. And then application of all that, whatever you know, to save the time is the software. So with the software, you only save your time, and with efficient way, the software will not make any mistakes. Okay. So I was talking about RCDC. So RCDC is a software that has been developed for design of elements. So the first thing is that RCDC will not analyze anything. That means you cannot create a model in RCDC. The meaning is that you have to take the help of some other software. So which software RCDC supports? The first thing is, as it is a Bentley product, it will definitely support your STAAD.Pro, and along with STAAD.Pro, it also support ETAP. Okay, so now we know that we have developed one model in ETAP. So we just have to get the results from ETAP, and then we'll go to RCDC and we'll design the elements. Okay, now we are going to concentrate on how to design a footing. Clear? Hello.
Yes, sir.
Yes, sir.
Now what is the basic requirement that you must know before, if you are asked to design a footing? So what is the preliminary requirement? Yes, can anybody name few requirements?
Load
Yes,
on the footing.
Okay, load on the footing, that is one parameter that you must know. What type of
And
load?
So-
if if
So
it is, it can be axial, and it can be that movement, biaxial movement also with axial load.
Right. So in short, I will say that at the top of footing, you must have vertical load, that is axial load, then lateral loads, maybe in X direction, maybe in Y direction, and a moment which is about X axis, or I will say moment about major axis, moment about minor axis. So these are the requirements that and where from you will get it?
Through analysis.
Yeah. So we have carried analysis. So we know if I go in analysis table, then I can find the reactions at base. So that is the first criteria. Now second, additional,
Soil bearing pressure.
right, soil bearing pressure. Okay, that is also you must know, or you have to assume. Either you can call geotechnical expert and ask him to submit the data for regarding the soil condition beneath the foundation, or you will assume based on your experience. Let us say you have assumed SBC. Then what do you need? See, this is the process which is carried in the software, right?
So then by using it, we have to first find the size of the footing.
That is okay.
Area.
Okay. But before that, let me give you one quick this thing is that you must know what material that you are going to use for footing. So grade of
Yes,
concrete
yes.
and reinforcement, grade of reinforcement. That is also a data. Then you must be aware which codal provision that you are going to use. So right now here we are going to follow codal provision as per IS 456. Right? Hello.
yes, sir.
Yes, sir.
So that much is the basic requirement before you go for design of footing. Okay. So before going to that for RCDC, I will just go quickly through this this process. So design of footing. See, this is very important. So how you can design a footing? First manually. So you can see what are the requirements. Design a footing for G+5, whatever may be G+10, it may be anything. Right now we are going for G+5 building procedure using IS 456-2000. So what is given? Given is grade of concrete, grade of steel, clear cover for reinforcement, column dimensions, net soil bearing capacity, and axial load. Now here we are not considering any moment. We are just saying that only axial load is there. Then how I can design it? Clear? So
Sir.
this is data. Hello.
Yes, sir.
Now after that, see the first step number one will be calculation of load. And what is that? You are given that 1500 kilonewton is the axial load on the column. Then self weight of footing. Now you don't know the size of footing, so you cannot calculate the self weight of footing, even though you know the self weight weight density of concrete. So that's why we are assuming 10% of this axial load. So 10% of 1500 comes out to be 150. So total weight on the footing, including its self weight, will be 1650. Clear? Hello.
Yes, sir.
Yes, sir.
Now the footing. See, this footing. Let us see. We are going conceptually. I'm not interested in formulas. Formula you can see in any book. If you understand the concept, then there are n number of books that will give you formula. See, what is that? This is the load. Okay. Let us say that this is including your self weight. Okay. Now, if you are having a footing over here, let's say this is your footing. So this is the elevation, and you can say this is your size, and this is your point where the column will exert a axial load on this footing. Clear?
Yes, sir.
Hello.
Yes, sir.
So this is L, this is B, and this is T. So design means we are going to find out what is the dimension for B, what is the dimension for L, and what is the dimension for T with our engineering knowledge. Now, what will happen when this load is applied on this this entire thing? It will be spread. Yes. So this is your area, and it will try to go something like this, right?
Yes, sir.
Now, here is your soil. Let's say this is your soil strata. Now, this strata will not allow this footing to go inside the soil. So, it will apply vertical load. And vertical load will be applied on this area. So, and this is your SBC. Okay. Clear?
Yes, sir.
Now, let us say that if area of footing is AF multiplied by PU, अगर ये सामना बराबरी का रहा तो SBC, whatever SBC is that, XYZ SBC is there, and area of footing multiplied by PU is exactly matching with this. What will happen? Tie होगा ना?
Yes. Yes.
Yes, sir.
Tie होगा. Now मान लो SBC is less than this. Hello. अब क्या होगा?
Yes, sir. It
इसका
will come down.
या ये क्या होगा, इसमें पेनिट्रेट होना शुरू होगा क्योंकि अपोज करने वाला कमजोर पड़ा। क्लियर?
Yes, sir.
Clear, sir.
नाउ लेट्स सी, ये ऐसा हुआ, SBC इज मोर देन एरिया ऑफ फुटिंग मल्टीप्लाइड बाय PU। तो क्या होगा, ये अपोज करने वाला ताकतवर है, इट विल नॉट अलाउ दिस। सो व्हाट यू नीड, see this is condition number 1, this is condition number 2, this is condition number 3. So which is favorable for from your point of view? See, you are a design
Condition number
engineer.
3, sir.
Yes,
Condition number 3, sir. SBC is more than.
yes. So SBC has to be more than whatever this calculation, right? But at least if you can say that even if it is close, then this will be your design equation. Clear? So I am writing design equation is something like this: PU multiplied by AF is equal to SBC. Clear? Hello?
Yes, sir.
Yes, sir.
Clear, sir.
Yes, sir.
So ये हमें जियोटेक्निकल एक्सपर्ट ने दिया, ये हमने एनालिसिस से निकाला, अब हमें ये निकालना है। तो क्या करेंगे, PU डिवाइड बाय SBC। क्लियर? हेलो?
Yes, sir.
Yes, sir.
Now this PU, actually I am saying it as ultimate. That means I have to convert it in working. So it will be PU divided by 1.5 or this P working. Clear?
सर एक डाउट था
Sir,
सर, अगर हमें एरिया निकालना है तो SBC अपॉन PU हो जाएगा ना, डिवाइड बाय PU, जो आपने किया है एरिया PU डिवाइडेड बाय SBC।
एक मिनट, क्या कुछ गड़बड़ हो रहा है? Just 1 minute. कुछ उल्टा लिखा हमने।
जी सर।
Area into
Actually,
SBC total.
ये ऐसा है, this is your kilonewton,
जी
this
सर।
is equal to area of footing multiplied by SBC.
यस सर।
Yes, sir.
Yes. ओ सॉरी, मैं जरा कुछ अलग ही सोच रहा था, तो गलती। एक्चुअली इट्स सी, दिस इज इन kilonewton,
यस सर।
so this is in mm square,
यस सर।
and this is in kilonewton per meter square.
यस सर।
तो इक्वेशन तो सेम यूनिट होना चाहिए ना दोनों साइड।
हाँ, यस
So actually see, this was your total force, and this was your upward soil pressure. Okay, so this
Yes,
will
sir.
be SBC multiplied by area of footing.
यस
Then
सर।
it will be kilonewton, and this will be kilonewton. तो
Then-
गलत लिखा हमने।
हाँ, देन ये बराबर होगा सर।
हाँ, अभी राइट।
Yes, sir.
Yeah, sorry for that, but actually गलत लिखा मैंने। Okay,
No.
so finally you are getting area of footing is equal to your working load, or you can say PU by 1.5 divided by SBC, because SBC is always given in working conditions. Okay, so this way you can find out area of footing, right?
Yes, sir.
now just again try to see the sketch. See, अगर sketch निकालते रहोगे ना तो आसान हो जाता है. See, this is your footing. Don't consider it inclined. It is actually horizontal. तो थोड़ा उस पर ध्यान मत देना, sketch पर ध्यान देना. So this is your force, and now you can see you are having upward pressure, something like this. Yes. So this is your W, or you can say PU. This is PU, and this is WU. So you can see that this part, this part is cantilever.
Yes, sir.
Yeah. So what will be the moment over here? If I call this as X, what will be moment over here? W
X square by 2.
into X square by 2. Right?
Yes, sir.
So this is the moment. This is the moment that you must resist so that your footing will not bend like this. Right?
Right, sir.
Right, sir.
ऐसा bend होता है ना वो. So that's why moment is calculated by this. Now this X is the projection. X is the projection. But now here you are not in one dimension, you are in two dimension. Let's say this is your footing. Right? And you are having a column. Let's say you are having column like this. And this is your projection. Yes?
Yes, sir.
And this is also your projection. Clear?
Yes, sir.
तो ये प्रोजेक्शन है और ये प्रोजेक्शन है. So this is Y and this is X. So if I call this as L and this as B, I can write equation L equal to, let's say this is the column dimension. So my column is this. And this is my beam dimension. So I can write L equal to D plus 2X. Right?
Yes, sir.
Or I can write B equal to B plus 2Y. See, this is my B. Y on this side and Y on this side. So you can see these are the two additional equations which will give you a dimension of L and B. Then one more thing is that area of footing is equal to
Length into breadth.
L into B or LF into BF. You can say LF for length of footing, BF for width of footing. Clear?
Yes, sir.
Now,
Clear,
if I want same moment on this side or on this side, I can say that X equal to Y. Because W, whatever is W on this side upward, the same will be on this side. So if I call X equal to Y, and that is called equal projections of footing on in the both directions. Clear? Yes.
Yes.
Yes, sir.
And that is exactly has been shown over here. You can check that. You will get this PPT, so don't worry about it. I'm not going to invest much more time into that, because you will get all these things for your reference also. You can see take equal projections on both sides. So if you can find out, you will find this equation where you will find x equal to 0.95, and then you will get projection. So also you can assume more projection than this, whatever. So take projection of 1 meter on both sides, and exactly that is what. And you can see the size of footing. So 1 meter. See, this is your width, 0.3 plus 2 into x1. Now x1 we are saying 1 meter. So you are getting 2.3, and here size of footing or depth of footing, longer dimension of column is 600. So 0.6 plus 2 into 1. So this is how you can find out the area of footing. So you can find L and B and then multiply it and see that area of footing is 5.98. Now this has to be more than the required area of footing. So what required area of footing that you have calculated? 5.5.
5.5.
So anything more than that will definitely be safe. Clear?
Yes, sir.
आसान है
Yes,
कि
sir.
नहीं?
Yes, sir.
Okay, now you can find out upward soil pressure. Now for upward soil pressure, see for SBC or deciding the area of footing, we are finding area of footing based on our working loads or unfactored loads. But when you are going to find out upward soil pressure, that is to be found out for load factor with factored load. So that's why 1.5 multiplied by 1500 into 5 divided by 5.98. So upward soil pressure that you are getting is 376.25. Then you can find out bending moment. So again, this Cx, whatever x I was saying, is here it is called as Cx. So you are getting equal to 1. That is what you have assumed over here. Okay. So you can find out Cx. So you can find out MUX, and that is coming out to be 188.125 kilonewton meter. Clear?
Yes, sir.
Clear, sir.
Then you can see the sketch, which will give you that idea. So Cx equal to 1000, Cy equal to 1000. That's why you are getting MUY and MUX same. So reinforcement calculation will be same. And now you can check Cy. So for Cy, again you will get 188, right?
Yes, sir.
Then you know the RC theory, depth of footing, required depth of footing. T MU is always equal to RU into BD square. ये पता है ना?
Yes, sir. Yes, sir. पता है. It's a depth निकालना है.
Right. Now here B we are considering 1000. So D will be square root of MU upon
RU.
RU. Clear? Or you can say RUB.
20,000.
You can say RUB.
Okay, sir.
The only thing is that make sure that you are getting the same units. So if you are finding out MU equal to kilonewton meter, then you have to convert it in Newton meter, Newton mm, because most of the time RU that you are getting as Newton per mm square. Right? Then
Yes,
B
sir.
is in your mm. So this has to be in Newton mm. So whatever mu you are getting, multiply it by 10 raised to 6. That will give you Newton per meter per mm square. Clear?
Yes, sir.
So you can find out depth means thickness. You can see
Yes,
over
sir.
here. So depth required is 265. You can see this RU is 133 FCK. You can get into your basic formulas where you will get that mu equal to RU
F
FCK BD square.
FE 500 it is 0.133. Yes, sir.
Yes. Okay. So based on that, this is the only unknown. Everything is known. This is known, this is known, this is known, and this is known. So you can find out D. So D is calculated at 265.94. Okay. Now you have to assume some diameter for reinforcement. See, the design is always a assumption and verification, trial and error. So right now, based on judgment, you may go for 10 mm or 12 mm. So here we are going for 12 mm diameter bar with clear cover equal to 50. Why 50? Again, you have to go for IS 456, where it says that for moderate environmental conditions, the footing must have a clear cover. Bottom of the footing must have clear cover of 50 mm. So you can find out that. So total depth will be 265 plus 50 plus half the diameter. So total depth comes out to be 321. You have to go more than this. And I will always say that most of the time go for at least two times this. Otherwise, you will have to revise your calculations later on, because you will find something problematic. So whatever required depth is, you can say, that's why we are saying that assume 600 and then reverse calculation based on D equal to 600. You will find D provided. So D provided is coming out to be 600 minus 50 minus 12 by 2. So 544. Required is 265. You are providing 554. And based on this required depth, you are finding out AST. So area of steel, 0.5 FCK over Fy into 1 minus square root 1 minus 4.6 mu upon FCK BD square in outside B into D. You can check this formula. Okay.
Excuse me, sir.
Yeah.
यहाँ पे सर ये ऊपर ओवरऑल डेप्थ D इक्वल्स टू 450 mm ये दे रखा है बोल्ड में, तो सर हमने तो 600 लिया है फिर ये
600 ये चेंज करना पड़ेगा, 600 करना पड़ेगा. ओवरऑल डेप्थ प्रोवाइडेड 600. ये पीपीटी में गलत हुआ है.
ओके सर.
या और 450 लेने के बाद आपको ये 544 तो नहीं आएगा ना.
यस सर वही.
तो नहीं वो गलत है. थोड़ा हम लोग भी गलतियां करते हैं बहुत बार. Anyway, it was not verified by me, but a person in our company has created this. But anyway, that is okay. You can check it. 600.
Yes.
So based on 600, you can see you will find out AST. So AST required is at 26. So the area of 1 bar, you can either calculate like this, or you can say safely 12 mm is equal to 113. Right? So 113 divided by 826.8 into 1000, you will get required spacing. So less than this will be provided. So we are providing 12 mm dia bar at 125 mm center to center. Now this bar will be provided in both the directions, right? Or you can calculate that and you can see the same is coming out, right? Now this check for one-way shear. when I said that you have to go for 2 times, because this later on, from strength point of view, your footing depth may be sufficient, but when you go for check for one way shear. Now I will just explain you what is this one way shear. पता है आप लोगों को या बोल बताना पड़ेगा? हेलो,
सर वो पता है सर, वो एक डी डिस्टेंस पे क्रिटिकल सेक्शन पे उसका शीयर में फेलियर हो जाता है फुटिंग।
ओके, थोड़ा थोड़ा सा मैं कवर करता हूँ, बाकी बाकी आप देख लो। See, if I am having depth of footing as D, then from this face of the column at a distance of D, see, if this is your depth, if this is your depth of footing, it gets shear off. So you will see a shear like this, and because of this, you will see your footing might shear off, and you might see a footing like this. Shear off हो जाता है. Bending point of view, it is okay, but it's a shear failure, and this part gets shear off. Okay, so at a distance of D from the face of footing. So this is called one-way shear, and you can see how that one-way shear is taken care, and then you can see that nominal shear stress. So see the concrete, this is the concrete. Hello, this is the concrete, and in this concrete, you have provided this reinforcement. Okay.
Yes, sir.
Now this reinforcement is taking care of MU. वो बोलेंगे नहीं नहीं, ये MU है ना, इसको हम बराबर रेजिस्ट करेंगे, बट ये shear जो क्रिएट हो रहा है ना, ये जो shear क्रिएट हो रहा है डाउन एंड अप at this level for this entire portion, ये shear है ना, this shear which is called VU, ये longitudinal reinforcement बोलते हैं भैया हम सारा काम नहीं करेंगे, वो ये कंक्रीट किस लिए, कंक्रीट को भी सस्टेन करना पड़ेगा. So what is the shear stress of concrete? So tau UC. Now if this tau UC is less than this tau U, तो ये shear off हो जाएगा. Okay, now
Yes,
that is taken care of here. You can see this is the nominal shear that has been calculated, which is VU max divided by B into D. So that has been calculated, and you can see that if this nominal shear is less than the shear coming from the load, then the footing will shear off, and that's why you have to increase the depth of concrete like this. Because this increasing the depth of footing only will take care of this, because this tau UC, which is the capacity of concrete or stress capacity of concrete, is not going to change unless you change the grade of concrete. But now we are going for some fixed grade of concrete. Now we are not going back. So whatever M20 has, and you can check it in your 456. So 456 will give you what is the shear stress that can be carried by M20. Now multiplied by this thickness into the width. ये ऐसा होगा ना, width of the footing and thickness of footing. So that will give you the stress that is coming from the due to the load. So that this has to be less than the capacity. So that is the concept. You can read it, and if you don't understand, then we'll see. Okay.
Okay, sir.
The same concept is explained here. So at a phase of D, what is happening? So you are getting this 456, and you can check it over here. Okay. And based on that, VU X shear force in X direction has been calculated, which is 171, and nominal shear stress, which is 0.2. So if you divide this VU max, then you will get whether it is. Now you can see. So percentage of steel. Now that is also considered. Some stress will be taken care by this. And now you can go to this page number 73, IS 456-2000. You will see that for percentage less than 0.15, tau C is equal to 0.28. So 0.28,
Yes.
which is greater than 0.2, therefore safe in one-way shear. Similarly for two-way shear. So what is happening for two-way shear? Again, I will just explain you that. Okay, we'll do it over here. Now, one-way shear is same or parallel, just like shear in beam, but this two-way shear is because of the two-dimensional form of the footing. See, this is your footing. And this is your column. So this is the column. Actually, this is the heavily loaded area due to PU, and it will be the stress or this P will be dispersed in this footing. So if I see, it's something like this. So it will be submerged like this. And that's why this area, you will see, if you find this area in both lines, so this is the area which is resisting your two-way shear. A shear which is having a two-way action is called a two-way shear. So this is the area which is resisting the two-way shear, and you can see that, right? Hello.
Yes, sir.
Yes, sir.
So that is calculated at the face of D by 2. So you can see D by 2, or you can see this as D by 2. Okay.
Yes, sir.
So this is the area, and if you try to develop a sketch, let us okay, I will explain you that. So इसके बाद आपको कभी प्रॉब्लम नहीं आएगा. What is two-way shear? आना नहीं चाहिए. देखो, ये आपका फुटिंग है.
Yes, sir.
लग रहा है ना फुटिंग?
Yes, sir.
Yes, sir.
और ये आपका कॉलम है. यस. और ये जो D by 2 का एरिया हो रहा है ना यहाँ पे, ये डेप्थ ऑफ फुटिंग, ये इतना एरिया वो पंच करके ज्यादा है। क्लियर हो रहा है?
क्लियर है सर।
सो दिस डेप्थ
यस सर।
is this depth, which is your depth of footing. I will call it as D. Okay. Then this is your D plus D. Right? Yes.
Yes, sir.
And if I call this will be B plus
D.
D. Clear? Hello.
Yes, sir.
क्लियर सर।
So if I call this as a perimeter, how much it will be? D plus B plus 2D. B plus D plus 2D into 2. इस साइड का और इस साइड का, इस साइड का और इस साइड का, तो D plus D, B plus D, so B plus D plus 2D multiplied by 2.
Clear,
यस
sir.
सर।
So this will be the perimeter. So I will call this as perimeter. Multiplied by depth. This, or let's say this. This will be the area that is resisting two-way action. Hello.
Yes, sir.
So that is what we are required to find out. And if this area perimeter multiplied by depth of footing multiplied by tau c, which is the capacity of concrete, has to be greater than or equal to Vc, which is the force which is driving. Clear?
Yes, sir.
तो बस वही है वो, और कुछ नहीं. Now you can go into that calculation. See, check for two-way shear. Depth of footing at critical section is 750. Effective depth of critical section D is 600 minus 50. ये depth of footing ये 750 नहीं 600 है. 600 minus 50 minus 12 by 2, 544. So B dash, which is 2 times perimeter of critical section. So this is the critical section that I have calculated. So it is coming out to be 3976. And then you can see that 1144 and 844 multiplied by 2, because 1144 on this side, 1144 on this side, 844 on this side, 844 on this side, multiplied by depth. Clear?
Yes, sir.
And that is what. And now how you are finding Vu? That is shear force on a shaded area, which is given by footing area minus critical section area, which is multiplied by upward soil pressure. So Vu is equal to area of footing minus, okay, for that also, if you draw, you will see. So this is your area of footing. Hello. And this is your area that is to be deducted. Right? So area of footing minus this area. So that will be the shear acting on a remaining area. Yes.
Yes, sir.
And based on that, you will calculate that nominal shear stress, and you can see this tau c, capacity of concrete. Again, this is one more factor, that is where Ks is minimum of 1 plus 0.5 plus Bc. All this is given in your 456. You can check it. And then 0.25 root FCK is tau c. So tau c is always considered as 0.25 root FCK. Ks equal to 1. So you can see the capacity is coming out to be 1.118, and this is coming out to be 87. So VUC, that is the capacity, is greater than VU, or you can say tau UC is greater than tau U. This is in Newton per mm square, and this is in Newton. That's all. This is a force quantity. Force is equated with force, and stress is equated with stress. And we are checking that tau UC has to be greater than tau U. That is what is shown over here. Clear?
Yes, sir.
तो आसान है. कितने लोगों को यह
Yes,
अब
sir.
आसान लगने लगा?
तो मैंने पहले ही पढ़ लिया था, तो अब और अच्छे से और क्लियर हो रहा है.
यस, जो पहले पढ़ेगा, सी हम कुछ नया नहीं, हम भी किताबों से निकाल कर ही आपसे बात कर रहे हैं. मगर अगर विदाउट थिंकिंग, मेरा कहने का मतलब यह है, इफ वी गो फॉर एनीथिंग विदाउट थिंकिंग और विदाउट इमेजिनिंग, then we do not understand what logic is going in that. Why we are equating tau UC with respect to tau U, why we are going for MU, and how we are finding the capacity, नहीं पता चलेगा. अगर इस ढंग से आपने देखा, so you can go through this. So this is actually a procedure that is used for calculation of or design of rectangular footing. Clear? Yes.
Yes, sir.
Now we'll shift to our original problem. अब मान लो, if I ask you to do the entire calculation for this footing, procedure is same. And how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. अब मान लो एक कॉलम का कैलकुलेशन आपको करने के लिए you need at least 10 to 15 minutes. Initially it is more than one hour, but let's say 10 to 15 minutes. And for this small building, you are having n number of columns. Then how much time it will be? You will have to spend. तब तक तो आपका क्लाइंट किसी और के पास जाके बिल्डिंग भी बना चुका होगा. Yes.
Yes, sir.
So for that, to save the time, the software is provided. That's all. मगर सॉफ्टवेयर आपको ये कुछ नहीं सिखाएगा. सॉफ्टवेयर बोलेगा आप मुझे फिगर दे दो, मैं उसके ऊपर जो आपने बताया वो सारा कैलकुलेशन करके आपको इमीडिएट दे देता हूँ. Okay, so let us see now. This is the model that we have prepared. In ETAB we have applied all loadings, lateral as well as vertical, etc. And now we have to analyze. But before that analysis, now we are going how to import this data in our RCDC. So for that, some procedure is important. Your model and see that the model is checked and it is not having any errors. और अगर errors है तो उनको निकाल के ही आपको analysis को जाना पड़ेगा. Okay, there are no errors, so we can go for analysis. So before going to analysis, one more thing is to be done. If you need this information to be exported in RCDC, and that process is that you have to make sure that you have to divide these beams in certain elements and columns also in certain elements. So again, let me show you the technique. See, let's say this is your beam. Now RCDC needs a result at various locations. Means shear force and bending moment diagram at this point, this point, this point, this point, this point. How many RCDC has a capacity, or it has been trained that each beam he will divide in 12 equal parts. So how many numbers will be there? 1 to 13. Clear? Okay.
Yes, sir.
So these are called as output stations. So output station number 1, output station number 2, output station number 3, 4, 5, and finally it will be output station number 13. Clear?
Yes, sir.
Additionally, if you are having a column and you want to design this column in RCDC software, then RCDC needs a result over here, a result over here, and a result over here. So how many stations? 1, 2, 3.
Three.
Okay.
Yes, sir.
Now this is the requirement of RCDC. So you have to put the output results. That means what are the shear force, axial force, bending moment, etc., over here. What is the result over here? What is the result over here? So every column RCDC needs 3 points, a result for 3 points, and for being RCDC needs 13 results. Okay, so that is achieved through providing output stations on beams and columns. So how we are going to provide the output stations? Very simple. Go to select, and in select go to object type, and in object type go to columns. Okay, clear?
Clear, sir.
Select, then object type, and under select object type you will go for columns and select
Select.
them and close. You will see all columns have been selected. Okay. Hello.
Yes, sir. Clear.
Now after selecting the columns, you have to go to assign, and as you have selected columns, you have to go to frame, and under frame you have to check that option output stations. Click on output stations and see minimum number of stations equal to 3. By default it is 3 over there, but if something else is there, then you can make it correct as 3, apply and close. Clear?
Clear, sir.
Then you have to select the beams. How many beams? All beams. How you will select it? Go to select, and under that go to object type, under that go to beams and select and
Close.
close. You can see all beams are selected, and then you will go to assign, frame,
Output station.
and output stations, and now here not 3, you have to go for 13. Apply
Okay.
and close. You can see these are the output stations that has been defined. Clear?
Clear, sir.
Then go to analysis and run analysis. So 3 stations per column and 13 stations for beams. Analysis करना है.
जी सर.
So analysis has been carried out. Now I will just go to undeformed shape. I will highlight it over here. Now the analysis file is ready. After that, I will go to file and then I will go to export. Okay. I will go to export and under export, this is ETAB tables to access. You have to choose this. Which one? ETAB tables to access. Then ETAB will create a table, a result tables for access. That is MDB file. It is called MDB file. And in that, you will say model and analysis. और डिजाइन तो हमने किया नहीं तो रिजल्ट है ही नहीं. Okay, so model and analysis. I am clicking on model and analysis and I am clicking on OK. Now ETAB will ask you in which unit you need. Now length unit I will select as meter and force unit I will select as kilonewton. Okay.
Yes sir.
Temperature unit, make it as it is because we are not going for any temperature analysis. And then he will ask you to save that file. Where you will save? You can save anywhere, but where you have saved your ETAB model, save it there. By default, you can see that we have saved it under my computer local disk D ETAB tutorials. Under that, now you can see here MDB file, and I will say save. अब थोड़ा रुकना पड़ेगा क्योंकि सारा मॉडल इंफॉर्मेशन as well as analysis information has been converted to from that tables. It is converted in access file, a file that can be accessed by someone else. Clear?
Yes sir.
MDB file. So that MDB file, you can see that MDB file is saving. We are saving that MDB, or I will say that software is saving MDB file on the address that you have provided. So it takes a little bit time and it depends on the size of your model. Normally 5 minutes, I think it will take not less than 5 minutes. And it will also depend on the capacity of your laptop or desktop or whatever you are using. तब तक हम कुछ नहीं कर सकते, एक दूसरे के साथ बात कर सकते. Yes, anybody wants to ask me anything?
सर आपने वो ETAB के अंदर डिजाइन ऑफ शेयर वॉल डिटेलिंग
अरे मत देखो यार सब चीज, वो तो बताएंगे बाद में. बहुत ध्यान से देखते हो उधर क्या क्या है वहां पे.
नहीं सर, मैं ध्यान से पढ़ता भी हूँ, देखता भी हूँ, और मैंने किया था एक बार तो नहीं हो रहा था, इसमें पूछा. उस दिन भी आपने कल की क्लास में बोला उसको बताएंगे नेक्स्ट क्लास में. अच्छा एक और इम्पोर्टेंट.
यस, समीर वांट्स टू आस्क मी समथिंग.
पर अविनाश जी को पूछने दीजिए, फिर मैं पूछ लूंगा सर.
हाँ ओके.
सॉइल प्रेशर कैसे कैलकुलेट करेंगे सर वो?
किसको करना है?
सर मैं पूछ रहा हूँ वो क्यों बेसमेंट में जब शेयर वॉल डालते हैं सर तो उसका सॉइल का प्रेशर तो पड़ता होगा ना शेयर वॉल पर साइड से, तो उसका कितना
हाँ, लेटरल लोड वो
यस
रिटेनिंग
सर,
रिटेनिंग का
हाँ रिटेनिंग वॉल का सर।
मैं बताऊंगा बाबा, उसको टाइम है। अच्छा, मैं आपको एक फाइल भेज देता हूँ, और उसमें देख लेना, ठीक है?
ठीक है सर।
डेफिनेटली वी आर गोइंग टू डू दैट इन आवर क्लास, बट आई थिंक उसको अभी टाइम है।
ओके सर।
Okay, Avinash, have you done any design for retaining wall?
नो सर।
तो रिटेनिंग वॉल का डिजाइन ऑफ आरसी रिटेनिंग वॉल का जिस बुक में वो बुक निकाल के वो प्रोसीजर देखो, द सेम प्रोसीजर इज अप्लाइड।
ओके सर।
बट कोई बात नहीं, we might go for some additional sessions, डोंट वरी। अनआंसर्ड नहीं रखूंगा, मगर थोड़ा समय लगेगा।
कोई नहीं सर। सर मैंने आपको फाइल भेजा है, एक मुझे दिक्कत हो रही थी जो व्हाट्सएप किया मैंने आपको।
हाँ हाँ, नहीं फाइल व्हाट्सएप किया क्या मेल किया?
मेल आईडी नहीं था आपका मेरे पास, तो मैंने व्हाट्सएप कर दिया।
नहीं, व्हाट्सएप का कुछ फायदा नहीं, मैं अभी मेल भेज देता हूँ तुम्हें, उस पर मुझे मेल कर दो।
ठीक है सर, मेल आईडी मुझे बता दीजिए।
कुछ नहीं, मेरा इनिशियल है S फॉर संजय, T फॉर त्र्यंबक, ST karkanis@gmail.com। यार ये टेकिंग मच टाइम। ओके, तब तक हम, यस समीर यू वर आस्किंग समथिंग।
यस सर, वो कोड से रिलेटेड सर, जो हमने मॉडल बनाया उसके लिए कुछ पूछना था सर। जैसे एक तो ये था कोड में सर, जैसे ये दे रखा था कि ओपनिंग अगर कंसीडर करें तो उस केस में सर ये डिजाइन लोड और वो फिर हमें कुछ परसेंटेज उसका वो चेंज करना पड़ता है। तो जैसे सर अगर ये जो हमारी स्टेयर केस की ओपनिंग होगी तो उस चीज में वो कंसीडर होगा क्या सर?
नहीं, ओपनिंग की वजह से कौन सा लोड यू आर रिड्यूसिंग?
एक सेकंड सर, मैं अभी कोड से ही बता देता हूँ, उसमें आज मैंने पढ़ा था।
For opening, actually, we see if the openings are in wall, then calculation of gravity loads, we are reducing some, but that is based on your judgment. कोड ने ऐसा कुछ बताया है, ऐसा मुझे तो नहीं लग रहा है, बट लेट मी नो व्हाट एग्जैक्टली यू आर आस्किंग।
सर वो इसमें दे रखा है सर, फ्लोर स्लैब्स हैविंग एक्सेसिव कटआउट्स और ओपनिंग, तो उस केस में पूछ रहा था कि
क्या?
वैसे स्लैब अपने अपने मॉडल में तो शायद सर कम है ओपनिंग, तो
नहीं
opening
होता है।
सर
Right, your question is correct, because there are n number of models where there is large opening in the every floor. In that case, but it is not reducing the load, because of that rigidity concept is not properly applied, and in that case diaphragm you have to consider as semi rigid.
यस सर, वो और डायफ्राम का दे रखा है। हाँ
नहीं, diaphragm is to be considered as semi rigid instead of that rigid.
यस सर।
So it is not about the load, it is about the diaphragm constraint that you are providing.
यस
So you are talking about 1893.
यस सर, 1893 में सर वो दे रखा था वो इसलिए पूछ रहा था।
नहीं, पूछना, सब कुछ पूछना, जो आपको लगता है ना वो पूछना। हालांकि सबका सवाल मेरे पास है ऐसा मेरा दावा नहीं है, मगर आई विल नॉट, आई विल गिव यू, इफ आई हैव द आंसर आई विल गिव इट।
सर
पूछने के लिए, या यस
एक चीज और पूछनी थी सर, उसमें इसी के जस्ट ऊपर एक वो दे रखा है री एंट्रेंट कॉर्नर्स करके है, तो सर ये जो हमारी बालकनी है ये उस चीज में कंसीडर होगी या नहीं? जैसे उसमें दे रखा है कि अगर 15% से ज्यादा है अगर हमारा वो प्रोजेक्शन, तो फिर प्लान प्लान उसमें तो फिर हमें 3 डायमेंशनल डायनामिक एनालिसिस करना पड़ेगा। तो सर उस केस में जैसे हमारी बालकनी है या इस टाइप से कुछ अगर ज्यादा एक्सटेंड हो रखी है तो फिर हमें वो करना पड़ेगा या नहीं सर?
यस 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 करना पड़ेगा। इसीलिए तो मैं हमेशा कहता हूँ, सी आई ऑलवेज यूज टू हैव डायलॉग विद आर्किटेक्ट्स। मैं कहता हूँ कि एज पर कोड यू आर नॉट सपोज टू गो फॉर कैंटिलीवर प्रोजेक्शन मोर देन 1.5। so whatever you are doing, that is up to you, क्योंकि in that case the vertical vibration comes in picture and you have to analyze the building as a three-dimensional analysis. So earthquake in x direction, earthquake in y direction, and earthquake in z direction, and in even then the performance of the building is under question. ऐसी कोई गारंटी नहीं है। दैट्स व्हाई यू कैन सी if you closely observe the high-rise structures, you will see that there are no projecting balconies. There are openings, but everything is inside
Yes.
the periphery. ये हमारे ये इंडिया के आर्किटेक्ट्स को अभी तक नहीं समझा है वो। If you see any European skyscraper, or there are a lot of buildings in constructed in Middle East, you will not find anywhere a projecting balcony which is projecting beyond the periphery of the building.
Yes sir.
Yeah, so it has got something problem, I think. I don't know he has created it or not. हैंग हुआ शायद, इतना समय नहीं लगता है।
रीस्टार्ट करना पड़ेगा सर।
अगर रिस्टार्ट करेंगे तो और प्रॉब्लम हो जाएगा। यस यस, अभी शायद वो कुछ कर रहा है। लेट मी सी वेदर द फाइल इज क्रिएटेड और नॉट। Yes, the file is there. See, this is the file. Residential building B19 or 01 created at 5/8/22/849. So this is, and you can see Microsoft Access. That is why it is called MDB file. Microsoft Access Database, MDB. Clear?
यस सर।
So now we can get rid of this E-tab. हम लोग बोलेंगे उसको थोड़ी देर के लिए बाय बाय, एंड विल गो टू RCDC. So this is the RCDC software. So double click on it. See, Bentley RCDC V8i, and okay, this is pirated, so I will say accept. This is not a authorized version. Authorized version के लिए आपको डेढ़ या $2.25 देना पड़ेगी। Okay, now you can see this is your first picture in RCDC, and here you have to name the project. So we'll say that residential building. भी जो नाम है दे दो, residential building. Okay, client, कौन client है? बैच नंबर 20। ठीक है, क्लाइंट का नाम इंजीनियर, कौन है इंजीनियर? मी। तो वो अच्छा है ना, सबको लगेगा यस आई एम द इंजीनियर। यस, हेलो।
यस सर।
Now here, see this analysis data. What he is saying, select statpro.std file, etab.mdb file, or etab.pdb file, or ram ss.rss file. So this is able to read all this. So we are having etab mdb file. So we'll go to the address. Okay, and in address we'll go to our where we have saved it. So we have saved it here and open. Okay, now the address where that mdb file lies is given to RCDC. Now he will read, and now he what he can do, he can design the element pile cap, footing, column and wall, beam and slab. So today we are interested in finding out footing. Clear? So I am highlighting footing. Yes. Hello.
Yes, sir.
And then you have to hit this create new project. Why new project? Because we have not done anything in this. So I will go to create new project. The moment he will start reading that MDB file. Now, if that MDB file can be read by this, then he will start doing that, and you can see how quickly he is reading everything. यही फाइल है आपका? Yes.
Yes, sir.
So you can now you can see whatever data that you have given in ETAB file has been read successfully, and he has marked columns, walls, everything. And now he is asking you, now इसके बाद ये सारा क्लरिकल काम है, अगर पता है तो क्या करना है? सेटिंग्स, क्लिक ऑन सेटिंग्स, जनरल सेटिंग। जनरल सेटिंग में क्या बोल रहा है वो? ओके, तो यूज ग्रॉस एसबीसी, ठीक है। देन प्रोवाइड टॉप स्टील, कहां पे प्रोवाइड करना है? फॉर ऑल फुटिंग, और यू कैन चेक इट ओवर हियर, प्रोवाइड फुटिंग इफ द फुटिंग डेप्थ इज ग्रेटर देन something, let's say I will say that if the footing depth is greater than 750, then provide top steel, or you may say whatever may be the depth, I want top steel at everywhere. Clear? Hello.
Yes, sir.
Now can you do you want side face reinforcement? If you want, you can highlight it. If you do not need, you can uncheck it. Then soil data. What is the soil data? He is asking net SBC kitna hai? Let us say net SBC that you are having is
300.
325. अच्छा 300 ले लेते हैं, 300. Okay. Then what is the soil density? That is 80. Footing depth. So you can go for maximum. So here you can say anything from 1.5 to 2, anything, or you can say 4 also, because if we are saying that, so up to 4 meter he will design, and you know that your footing is not going to have a thickness equal to 4 meter, so you can say 2 meter. Water table है क्या वहां पे? है तो लिखो. Okay. Then go to this permissible loss of contact. See, entire footing should have a soil contact. That means permissible loss of contact is 0%. Clear?
Yes, sir.
Design parameter, क्या parameter देना है? You can check any parameter over here. Let's say you want
Okay.
M25.
Okay, sir.
Steel grade. What steel grade? ये इतना steel grade available है. You can say Fe415. Clear cover. Footing के लिए कितना clear cover देना है आपको?
25 mm.
50
50 mm.
50
हाँ,
50
ये
mm.
लाइव लोड रिडक्शन करना है. अच्छा, वो किसने मुझे पूछा था वो लाइव लोड रिडक्शन क्या है? दिस इज हियर व्हेन यू आर डिजाइनिंग अ फुटिंग और यू आर डिजाइनिंग अ कॉलम्स.
यस यस
किसी ने
मैंने
पूछा
पूछा
था.
था नंबर ऑफ
हाँ,
स्टोरीज.
yeah, it is depending on number of stories, and maximum is shown over here, but you can say that okay, I don't want any reduction, so in that case you can put it as uh, say 0, or I will say that live load reduction. So I will say that 40% reduction is allowed. So you can reduce 40%. Then type of soil, कौन सा soil है? Hard है, medium है, soft है. तो ये medium है. 325, 300 means it is a medium. So don't see, sometimes you will put over here as 1000 and here you will say that it is a soft soil. Not like that. So this has to be connected. So these are the connecting things. Okay. Okay. SBC increase. Earthquake में कोड ने आपको 25% इंक्रीज अलाउ किया. You can keep it as it is. Wind 25. PCC thickness below the footing. क्या आपको PCC चाहिए? हाँ चाहिए. कितनी चाहिए? 100 thick, 200 thick, 150 thick. You can provide it. Then offset. Offset यानी what is the horizontal offset from the edge of the footing? You can say anything. So 150 is the normal condition. Round up. Again, these are some mechanical things. कितना मान लो अगर उसने कैलकुलेशन किया कि साइज ऑफ फुटिंग इज 1213.5, तो क्या वो साइज देंगे आप? क्या राउंड अप करेंगे? तो राउंड
ऑफ करेंगे सर.
So you can say round up. So here plan round up. You can say plan round up maybe in terms of 25, and depth round up you may say 25, or you can say plan round up as 50 and depth round up as 25. Then minimum steps. So whether you are going for step footing or not. So the maximum steps allowed is 5. So you can say that, but minimum depth. So here this is maximum depth that you can say. So keep it 0 so that he will consider whatever he needs. Then minimum depth 300. So sometimes your column may be subjected to very less axial load, so it might need a depth less than required depth less than 300. In that case you will say that at least 300 तो रखो बाबा, ऐसा मत करो कि 100 mm का डेप्थ दे दो. सॉफ्टवेयर दे सकता है कुछ भी. तो you are asking him that minimum 300 should be maintained. If it is anything less than that, then provide 300. If it is anything more than that, then provide whatever that you have calculated. Okay. Then plan limits you can set. Okay. Then this cross section design average pressure, and click OK. तो एक सेटिंग हो गया. रीएनफोर्समेंट सेटिंग. क्या रीएनफोर्समेंट सेटिंग आपको क्या चाहिए? रीएनफोर्समेंट में रीएनफोर्समेंट एरिया मिनिमम बॉटम रीएनफोर्समेंट. So here you must have what are the requirements that has been given in IS 456. So 456 it says that minimum bottom reinforcement shall not be less than 0.12%. Okay. Maximum top. So maximum top can be something around that. So minimum top, I will say that 2%. So you can say 0.02. Okay. Then maximum bottom. So bottom में maximum percentage कितना होना चाहिए? So it can be anything. So I will say whatever it, you can say anything, because he will calculate, and then so maximum top 1.5. Now whenever something is, then he is asking, see, permissible range is from 0.06 to 6, so you can say 4. Then maximum top में maximum आपको कितना चाहिए? ओके, उसने लिया। फेस रीएनफोर्समेंट, आपको साइड को रीएनफोर्समेंट चाहिए क्या? तो कितना? तो यू कैन से 0.05. देन रीबार स्पेसिंग, सो मिनिमम लॉन्जिट्यूडनल कितना स्पेसिंग होना चाहिए मेन रीएनफोर्समेंट में? मिनिमम, मैक्सिमम क्या है? मिनिमम एंड मैक्सिमम, एंड देन ही विल
मिनिमम 100 सर।
Yeah, minimum shall not be less than 100. Then maximum shall not be more than 300. Then preferred is 100. And shear. Now the shear, actually we are not going for stirrups to be designed as in footing. So whatever is there, you can and then spacing around of 5 mm. Now here rebar, मेन स्टील में मिनिमम कौन सा चाहिए? अगर आपने यहाँ 10 लिया और 10 से उसका काम हो रहा है, सो ही विल यूज इट 10, अदरवाइज ही विल गो फॉर लार्जर. मगर अगर यहाँ पे 12 दिया आपने मिनिमम, और इवन इफ इट इज नॉट रिक्वायर्ड, ही विल से दैट 12 mm. ओके, सो मिनिमम विल गो फॉर 10, and minimum top steel will go for 10, and maximum I don't want anything maximum than 16, so I will say that 16 से ज्यादा नहीं चाहिए. Okay, then shear के लिए also you can go for 10 and 12. साइड फेस reinforcement, साइड फेस का reinforcement आपको कौन सा चाहिए? 8, 10, you can go for 10. Maximum you will say that not more than 12, and this is this 8, 10, 12, 16, 25, 32. This is rebar diameters available. Click OK. क्यों नहीं ले रहा? ओके, थोड़ा समय ले रहा है वो. ओके, then settings, detailing and drawing settings. Okay, this RCDC gives you detailing also. That is the best part of this RCDC. He will give you RC drawings also. तो बॉटम स्टील वर्टिकल लेग आपको फिक्स डिस्टेंस चाहिए या आपको फैक्टर से चाहिए? तो you can go for that. Normally we'll say that for this type of building you don't need vertical bent up more than 150, or sometimes if you are having say depth of footing is something around 1000 etc., in that case 150 is not sufficient. So we say that in terms of factor d/2 or d/3, whatever you feel. But right now I am choosing this, but you can choose anything. Software has that facility. Then top steel vertical leg. Top steel का vertical leg का distance कितना है? This also I will go for 150. Or you can go for that factored as per your choice. Then overlap को हमको चाहिए नहीं, so we are not going for that. Then face reinforcement, वो जो side face reinforcement आप दे रहे हैं उसका लैप कितना चाहिए आपको? तो you can say 300. Okay, level for elevation, आपको levels लिखना है क्या और क्या लिखना है? अगर reduce level लिखना है तो he will write it like this, और use levels लिखना है तो he will go as per that. But you can check this with this PL, then drawing scale. आपको जो footing का drawing चाहिए उसका scale क्या चाहिए? You can check it. So there are two scales available. So out of that, maximum scale that you are choosing 1:25, and you can click OK. Settings क्या हुआ? Crack width करना ही नहीं है. Crack width कहाँ पे है? Water retaining structure में you will have to go for crack width settings. It is just following for codal provision as per IS 456, and this is what basic load cases. यहाँ पे आपको क्या करना है? बेसिक लोड केस यहाँ पे उसका टाइप लिखना है. ये क्या है? डेड है. EQX क्या है? सिस्मिक है. तो उसमें क्या लिखा है? अर्थक्वेक इन एक्स डायरेक्शन. ओके. EQI क्या है? अर्थक्वेक इन वाई डायरेक्शन. ये क्या है? दिस इज लाइव लोड. ये क्या है?
रिस्पॉन्स.
रिस्पॉन्स. मगर इसमें उसको क्या करना पड़ेगा? रूफ लाइव, स्नो, टेम्परेचर एक्सेट्रा. इसको ये यही लिखना पड़ेगा बिकॉज शी डज नॉट नो. एंड SDL. SDL क्या है आपका? Either you can go for dead or you can go for others, but I will prefer dead. Okay.
Okay, sir.
And this is what analysis load cases, load type, etc. Primary load cases. So I will send it to that. Okay, one by one जाना पड़ेगा. Now this, for designing, you can say add from analysis. Do you want to remove? Okay, duplicate remove करना है. Okay. Now all these combinations has been taken as per our codal provision based on whatever primary load cases that you are given. Okay. Okay, please add sizing and load combination. Yes, sizing के लिए भी उसको add करना है. Add from analysis. And say yes. So now sizing is considered with the help of working load. So that is asked by that. Then you can go to settings and setting is complete. अब क्या करना है? कुछ नहीं. आपको यहाँ पे जाना है, ऑटो डिजाइन करना है. ये देखो, ये स्टार्टेड डिजाइनिंग. वो सारा डिजाइन दे दिया. क्लियर? देख रहे हैं आप?
एक्सक्यूज मी सर.
यस.
सर जैसे फोटिंग के डिजाइन में सर जो हमने EQX और EQY और ये लिए हैं, पर सर उसमें कोडल प्रोविजन में जैसे मैंने पढ़ा था उसमें दे रखा था कि प्लिंथ के ऊपर या फिर प्लिंथ लेवल तक हम अर्थक्वेक फोर्स कंसीडर करते हैं, फुटिंग पे नहीं होता. तो वो चीज कंफ्यूजन थी कि या फिर इधर हमने EQX कैसे.
नहीं. See, all primary load cases मैंने यहाँ पे ले लिया है. But whatever you say, that is right. नॉर्मली सी नॉर्मली मैं तो नॉर्मली यहाँ पे ग्रेविटी लोड्स ही लेता हूँ. I don't go for any lateral loads. See what is happening. This footing when you the columns you have given the uh, results. There might be moment, and because of that your reinforcement may be increased or your size may be increased. So that is checked over here. But
Yes.
yeah, definitely the below ground, you cannot say that earthquake is acting because below ground, though there is a vibration, it is a rigid vibration. And as a structure engineer, we are not worried about any rigid motion. We are always worried when there is a differential settlement or when there is differential deformation.
Yes.
See, stresses will come in any element only when it will deform. See, if it is moving, then there will be no stresses. Just you can imagine that uh, uh, you are going somewhere by your car, and your car is moving, but the car will not find any stresses on the body. It will find a stresses only when it will get deformed. मीन्स कहीं जाके वो डैश हो गई या साइड से किसी ने उसको गाड़ी को धक्का दिया तो उसमें जो डिफॉर्मेशंस विल क्रिएट द स्ट्रेसेस.
Yes.
So rigid body movement for civil engineers or structure engineers, we are not worried about rigid body movement. अगर पूरा का पूरा अगर साथ में डिस्प्लेस होता है तो we are not worried about that. We are
Yes.
worried only when there is a differential deformation. One point is not moving, but the other point is getting deformed or moving, and because of that, the lengthening of the element is coming in picture, or shortening of the element is coming in picture, and then only internal stresses will come in picture. So that's why the earthquake forces are not considered for design of footing. So whatever you are saying is correct. Actually, I'm showing you how it can be used. Okay.
Yes, sir.
Yeah. Now you can see you have got the design. So you can check it over here. So your footing number 1. So it is column number 3, column number 6, 15, 18. You can check that over there. So the red light you are getting over there as you see this, or I can highlight this. Yeah, see, this is your footing. So you can see that it is a pad footing. Material is M25 AP415. Column size is 230 by 900. That is what we have given, and footing size is 2100 by 1450 by 450. So depth is calculated, and you can see loss of contact is always 0 because we have not asked him to for that. So bottom reinforcement Tor 8 at 105, and bottom reinforcement in width direction Tor 10 at 125. So this is how you can get it. So this, yes,
सर
somebody.
ये बॉटम रेफोर्समेंट T10 @105 105 क्या स्पेसिंग है?
Yeah, spacing.
ओके सर.
Then you can go for reports. So if you go to reports, click on it, and he will ask you what report you want. Are you interested in design summary? Okay, you can click on that, and you will get the design summary. So for every footing, you will get a summary like this. So footing number FC3 column is C3, pad, M25 this. So this is the required reinforcement. So top reinforcement and bottom reinforcement, parallel to length and parallel to width. So this is the summary. अच्छा है ना, क्विकली मिलता है.
यस सर.
सिर्फ आपको इनपुट आपका करेक्ट होना चाहिए. Okay, then I will go for another. Say I want a schedule. Let will ask him what. या ड्राइंग ही दिया उसने. आपके लिए कुछ काम रखा नहीं उसने. देखो, footing schedule, FC3, C3, pad. Then there are no steps because we have not asked him to go for steps. So you can see LB. So length of the footing, width of the footing, D1 and D2. D2 will come in picture when you are going for step footing. By the way, step footing पता है? Hello.
Yes sir.
कुछ लोग ऐसा footing कर दे.
यस सर.
So in that case, you will say this is D1 and this is D2.
D2.
Okay. Right now we are not asking him for this type of footing. So, but you can ask. कुछ भी पूछो मैं दे दूंगा. और उसका पैसा भी नहीं मांगता वो. एक ही बार लेता है वो 1.5 लाख. ओके. footing reinforcement. So along B, along L. So this is about top, this is about top, and this is about bottom. So you can get in vertical format. अब कुछ लोग बोलते हैं नहीं सर हमको वो वर्टिकल में अच्छा नहीं लगता, हमको हॉरिजॉन्टल में चाहिए. So you can ask him and he will give you in horizontal format. वैसा लो. ठीक है.
जी सर.
ओके. नाउ अब इससे भी बोलते नहीं डिटेल ड्राइंग भी दे दो. तो ठीक है भैया डिटेल ड्राइंग देता हूँ. ये सारा. ओके. सो I will say you one or two. Let's say we'll go for F6 or let's say F3. Okay. यहाँ पे उसने वो सब दिया है आपको. डिटेल ड्राइंग क्या चाहिए, सेक्शन चाहिए क्या, चलो हम सब मांग दे. उसको बोलते प्लान भी दे दो, सेक्शन भी दे दो, सेक्शन इन लेंथ में दे दो, सेक्शन इन विड्थ में दे दो. देन फुटिंग लेआउट, ड्रॉ प्लान, मार्क सेक्शन इन प्लान. ओके. देन section number, set start value 1 and accordingly go for other numbers. Then mark PCC. अच्छा PCC all footing में चाहिए, सब कुछ चाहिए. And this will be for all footings. You can see detailed drawing for this footing. उसने दे दिया.
सारा चीज दे दिया.
क्लियर?
यस सर.
क्लियर सर.
जो आपने उसको सेटिंग दिया ना, वो सेटिंग को यूज करके उसने सब कुछ दिया. अब इसमें से आपको क्या चाहिए क्या नहीं चाहिए आप डिसाइड करो, और सबको चाहिए तो सब ले लो. ठीक है.
ठीक है सर.
देन गो टू रिपोर्ट्स. अब इससे भी नहीं ना, पीपल से नहीं वो कैलकुलेशन भी बोलो ना तुम्हारा सही है कि नहीं है. ये लो कैलकुलेशन भी ले लो. Okay, now this is very interesting, and this I like this facility because this is the facility only in RCDC, and actually I like this only for this. And for newcomers, जिनको design of footing पता नहीं है ना, and code कोड में कौन सा क्लॉज पढ़ना है, कब पढ़ना है, वो देखो यहाँ पे वो कोड रेफरेंसेस IS 456। अगर PT मैक्स के बारे में देखना है, क्लॉज नंबर 26.5.2.1 दे दो। PT मिनिमम देखना है, क्लॉज नंबर 26.5.2.1 देख लो। ये PT क्या है, तो क्लॉज नंबर 38 देख लो। अच्छा, ये टाउसी क्या है, क्लॉज नंबर 40.2.1 देखो। अब इससे ज्यादा और कुछ चाहिए क्या आपको?
नहीं सर।
नो सर।
Now with the help of this, you can read your 456 and find out the meaning for all these things, right? And based on that, he is giving you the calculation also. See, this is the for column C3, that this is the size that you have submitted through your ETAB, and based on that, whatever information that you have given, he has shown everything. You can check it. Self weight plus footing weight, it is calculated like this. So offset along L, offset along B. Check for maximum soil pressure. वो कौन से क्राइटेरिया को उसने मैक्सिमम सॉइल प्रेशर काउंट किया है, कैसे किया है? सो क्रिटिकल लोड कॉम्बिनेशन इज 16, that is STL plus dead load plus live. Then MX, MY, P by A, M by Z, M by ZY, all that is given. Then check for minimum soil pressure. So minimum soil pressure में उसने वो seismic weight criteria check किया है. And there's design for bending, bottom reinforcement along length, top reinforcement. You can check this. Yes. अब इतना डिटेल तो कोई नहीं देगा आपको,
नहीं सर।
बस आपको पढ़ना है। और इससे ना जो चीजें आपको नहीं समझी ना कि लोड ट्रांसफर चेक हो, तो यहाँ पे देख लो, and then you can with reference to your books that you are using, you can improve your understanding. So this design calculation is the very best part for this.
BBS भी दिया है सर इसमें तो।
Yes.
BBS बार बेल्टिंग शेड्यूल।
या वो ठीक है यार, वो BBS जनरेट BBS दे देगा। मान लो मुझे इसका ही चाहिए, तो the only thing is that this input is to be given to him. You can check this. Mostly why the people all over world, they are using this only for this. पूरा ऑफिस में पूरा काम हो जाता है। तो समरी फॉर FC3 को आपको बार डायमीटर 10 है, so you can see this and weight in kg and weight in this LGT. I don't know what is this LGT. मैं इसमें ज्यादा ध्यान नहीं देता हूँ। So this is the weight that is required for this. Yeah, longitudinal, and I don't know, I will have to see that 88 and 55. So bar mark, bar numbers, bar dia, bar shape, cutting length, ABC. So A is this much, A is this much, B is this much, C is this much. Together it is 1588.
यस सर।
And this R is that curvature. I think that curvature, ये यहाँ पे वो bending curvature है ना,
यस सर वो
है. That is okay. Yeah, you can check all that. So this is how you can carry out the footing. But I will say that use this for your understanding purpose. ये आज की जनरेशन का प्रॉब्लम क्या हुआ है कि they have the hands to software, so they are not going manually. So that's why actually today I was not supposed to go for manual conceptual understanding that you should understand, but I don't like that. जब तक नहीं समझता है ना कुछ फायदा नहीं.
Yes, sir.
So you can get that PPT also. I think it might have been provided on the classroom, but if it is not, tomorrow I will ask the Pradnya madam to upload on the classroom. So we have every PPT, that is PPT for footing, PPT for columns, beams, slabs, manual sample.
तो
Yeah.
प्रोवाइड कर चुके हैं सर वो.
अच्छा, प्रोवाइड किया है तो
यस सर.
हाँ, तो you can download and you can go through that. And I think most of the time next session will be conducted by Anil sir, but you will get notification on classroom. Here I would like to conclude today's session. If you have any query, you can ask me. It's 9:28. Half an hour, that was West. I was talking about that manual. Otherwise, I could have finished before 9. आप लोगों से कुछ लोग बोर हुए होंगे, बट
No, sir.
यार
सब रिवाइज हो गया, छूटा हुआ था सब.
नहीं, वो बहुत जरूरी है कि see why I am saying this again and again, because when I go for interviews with people, they literally do not know anything, and I don't know, they are having marks in MTech more than 70%, 80%, and they have no idea how it is carried out. नहीं वो बोलते वो होता है. अरे ऐसे कैसे होता है? मैं आपको एक एग्जांपल देता हूँ and you can think of the level. मैंने वो स्टूडेंट को सिंपली सपोर्टेड बीम ड्रॉ करने के लिए बोला, तो उसने ऐसा ड्रॉ किया. Okay, so this was simply supported beam. Okay, I said that then draw the fixed beam. तो उसने फिक्स बीम ऐसा ड्रॉ किया. कैसे लगता है?
हाँ सर.
बढ़िया लग रहा है सर.
So this is simply supported beam and this is fixed beam. I said, why you are saying it is fixed? Sir, this is fixed at top. And that fellow was a postgraduate student from one of the university. I don't know from where. दो दिन मुझे ही कुछ समझा नहीं. मैं बोला क्या करूं यार इन लोगों का. और एक किस्सा बताता हूँ, जस्ट इफ यू हैव अ टाइम.
बिल्कुल सर.
I said this is a shed. This is a shed having B and L, and this is a factory shed, and I want trusses to be provided on this. How you will provide it? मन में सोच रहा था कि अगर वो पागल होगा तो बोलेगा सर मैं ट्रस ऐसा प्रोवाइड करूंगा. Right? Actually, trusses should be provided like this. Yes. Hello. Clear?
Yes, sir.
मैं सोचा शायद उसको ये नहीं समझा. He will say that trusses will be provided like this. मगर उसने क्या किया? He provided a truss like this. प्लान में ही उसने ट्रस निकाला. So these are the, and that's why I am really worried. और चाहता हूं कि शायद आप लोग ऐसा कुछ ना करें. ठीक है?
Yes, sir.
Yes, sir.
With this we'll conclude today's session and we'll meet in next session for design of columns.
Okay, so good night.
Good night, sir.
Good night.
Good night.
Good night, sir.
Good night. Good night.
Thank you. Good night.